To this new video where we're going to be looking at quicksort algorithm. Now, excuse the last video, I mislabeled insertion sort as quicksort. So this is quicksort. The other one was insertion sort. So how we do this is, let me explain what quicksorting even is. We have an array first because we're gonna do sorting arrays. So we're gonna say the array is gonna be 1, 3, 2, and then we'll also try different arrays. We'll also try the array, I don't know, 3, 2, 1. Now the vital thing in quicksorting is something called a pivot. A pivot is basically an element you choose such that you partition the array in 2 pieces. Okay, and there's going to be one part that is lesser than this element and one part that is greater than this element. So what I mean is, if 4 is a pivot, we're just going to be comparing the elements now, not any positions. So 4 is the element, and we have another element 6. Well, 6 is going to go into one of the partitions, while if we have an element like 1, it's going to go in the other one. So we're going to call one of the partitions the lower part and one of the partitions the higher part, where the pivot is the middle element. Okay, it's the element that lies in the center when you consider a sorted set. Okay, so just some terminology. Now let's go over this. Okay, I'm going to use 1 as the pivot. Okay, the first position as a pivot in general. So for this one we're going to use 1, this one we're going to use 3 as the pivot. Now what I'm going to do is, I know that my first position in the array, the 0 position, because it's 0 indexed, is the pivot. Okay, because I said it is a pivot. Now I want to find a place to put this pivot after establishing the lower part and the higher part of the array. Okay, so one interesting implementation that I'm going to do is, I'm going to say this last position is going to be like a cup. Okay, it's going to hold a position for us. Okay, think of it as someone literally holding a parking spot for you. Now if you find an element that is larger than the pivot, we're just going to put it in that temporary position. So we're going to tell this person that's looking after your parking spot to find a person that is bigger than this certain number, or like find this random number that's bigger than this number, and if it is, then just switch positions with it, and then look after the next parking spot. So this is literally the implementation. That's like I think that's a good analogy for the implementation. So now 2 is in this temporary position. Okay, but now we're interested in the position of 2. Well, 2 is in the let's say the array is A, it's in the A2 position, okay? Okay. Now we're going to go backward from the list, okay? We're gonna say that I'm gonna start at the last element of the list, the last position, which is also 2. We're gonna check if 2 is lesser than, if 2 is greater than the pivot. Well, 1 is the pivot, and 2 is definitely greater than 1. So we're gonna swap 2 with 2, okay? Now, it might be a stupid thing to swap 2 with 2, but this is not the best example to show why it's useful, but it would make sense if there was, say, an element that is lesser than the pivot, then we're not going to swap it, and the position of our pivot later on will kind of adapt to that. I'll try to explain that more when we're implementing it, but for now we're gonna go reverse. So we're gonna look at the last element. Is it bigger than the pivot? Yes, it is, so swap it. Now hold this position for me. Now we're gonna look at this element. Hey, is 3 smaller than the, is 3 greater than the pivot? Well, yes it is, so we're gonna swap 3 with 3. Okay. And then this is going to be our final temporary cup position, okay? Temporary person who's looking over a parking spot for us. Well, interestingly, that's our pivot spot. It all worked out, right? Now we have 1 is our pivot, and 3 and 2 is our own sorted array. It's sorted, meaning it's going to be sorted. We're going to put this back into the quicksort algorithm recursively. What that's going to do is it's going to sort 3 and 2. It's going to make 3 the pivot, and then it's if we do this implementation on 3 and 2, then guess what? Well, 3 is going to be our pivot. 2 is not larger than the pivot. So nothing will change in the first phase of the implementation, but after we've gone through iterating the list, so gone through 2 only, we're never going to look at the pivot position until we finish iterating through the list and to see what's greater than the pivot, because we don't want to compare the pivot to the pivot. Okay. Now at the end, we need to note that we need to swap this pivot with this position, this one temporary position, and then it gets sorted magically. Now in this implementation, 3 is our pivot. Okay. Now 1 is going to be our first temporary position. Now 1 is not greater than 3, so we're not going to switch, okay? But we're going to move the position here. Now they're going to hold this temporary position. No, actually, we're not going to move the position even, because we haven't switched anything around. Our person has not done their job yet, okay? Now they're just going to wait there. They're going to look at this number. Oh wait, 2 is not larger than 3. Now what do? We are not going to look here because this is our pivot position. Our pivot, think of it as the manager of this person. They're not going to tell their manager to stay in this parking spot. So we're going to ignore the pivot position. Okay. But now at the end, hey, the person has fulfilled their job. They couldn't find anyone. So now their manager, they want to show their manager that they've done their job. So why don't they switch? and then it's sorted. We get 2, 1, 3. Then we're going to sort the left part of the list 2 and 1, and the pivot is in its proper position. We've sorted the pivot. That's what you should think of it as. Okay, now I've gone on too long with this. Okay, so I'll avoid including anything right now. We'll just try to manipulate the array first, and then we'll go through a printing implementation maybe, and include the standard input-output interface. Okay, so let's get int main void. Now make an array. I want it to be an integer array. Let's have it of size 7. Why not? So let's just do 7, 6, 5, 3, 2, 4, 1. Okay. Now the array length. We're not gonna do the array length. Okay. We'll talk about this right after. Okay. We'll just say quick sort. Now remember how I said that we need a first and a last element, which is going to be very useful to us. So, well, our first position is 0. Let's give it our first position. And our last position is what? 6, because it's 0 indexed. Okay. Now let's implement quicksort. Okay. We've done all the necessary parts. Now we can implement quicksort. Now to implement quicksort, we need our parameters. We need to take in the array, and we need to take in the first position. I keep saying element, excuse me for that, and the last position. And what we're going to do is we are going to first set the pivot position. But actually, before that, if we were to give our function an array of length 1 or less, well, if it's length 1, it's already sorted, right? So if the first is equal to the last, then it's sorted already. And this is our base case for recursion. We need to end our recursive calls, okay? So we should write our base case here. So we need our base case. Let's say first is greater than or equal to last, because if first is greater than last, then that's not a proper array. We're just gonna return nothing. Okay, we could leave it blank. We're just gonna return nothing. Then we're going to implement. Okay, so our implementation is going to consist of a pivot. Our pivot is going to be an element, because we need to compare the elements. Okay. It's going to be array first. Okay. Now we need our position. This is our temporary parking holder, based on the analogy. They are going to be just the last position of the array. Okay? Just gonna hold the last position of the array for us. Now let's give this person their function. Okay, let's give them their job. Okay? Think of this for loop as this position holder's job. Okay. So how are we going to implement this? Well, we want to ignore the pivot. ignore the first position. How do we do that? Well, the simplest thing is just make a random variable that starts at 1. Right? Easy enough. No, we want to go backwards. The pivot is the first position. Okay, so let's try to implement it in a more simple manner. Okay, let's say this starts at the last. Now we can just say I is greater than. What does I have to be greater than? Hint, the first position. By doing so, we're not going to touch the pivot. And then we're just going to subtract I. Okay. Now we need a swap function, so I'm going to quickly implement that. You can look at the old videos to see how to do these swap functions. There you go. We have a swap function. Now, as I said, we need to compare the pivots. Okay, so if pivot, well, let's say array I, the ith position of the array. I'm gonna start by the end. If this is larger than the pivot, okay, then what are we going to do? Well, we're going to swap this position. Okay, so swap at array I with what? What do we swap it with? Well, we swap it with the last position. Okay, hope that makes sense, because if your temporary guy is holding this one spot. Wait, I made a crucial mistake. It can't be the last. Okay, it needs to be the position, because we want to keep changing his position. My bad. We don't want to change. Let's keep the last constant. Okay, in this case. Okay, we're going to switch it with this position, and why we're going to do this is because we're going to also, if something is greater, we need to change his position. So position minus minus. Okay, so what we're doing now is, if this is greater than the pivot, for example, then we're going to put this in this position, but it's not. The position is going to stay here for the implementation. And then at the end, we're going to swap these two. How about we quickly implement this ending, since it's very conceptual. At the end, we want to swap array first. Okay, the first position with this position. Okay, now we've completed this implementation, except for the fact we haven't sorted the first part of the array and the second part of the array. So we need to do that, right? Let's do it. So let's say quick sort. Before we do this, we need to keep this swap again. Otherwise, we're going to be essentially putting the pivot in again. Quick sort. But now, we want to look at the same array, okay? But the first element is going to stay the first element. First position. But the last element is going to be the position -1. Okay. Then we're going to do the same thing, but for the larger partition that we have, then we're going to start from position +1, because we want to say our pivot position was, say we have something like, I don't know, 2, 3, 1, then our pivot position is at the end is going to be here, so we're going to have 2, 1, 2, and 3. And then we want to sort this part, which is first 2 zeros, right? So it's going to be we're going to essentially give it array 0, 0, and it's basically sorted already, so it returns itself given our base case. Hope that makes sense. So if we sort this and then we sort it towards the last of the list, then we should in theory be going over the whole sorting. Now let's run and just see if our function works. Okay, there's no any errors, no errors. Let's make our include. Let's do some testing. I'm going to say for printf, so it's easy so you understand what that's for. Let's make a print array function. We give it an array, give it the length of an array, so int array int array int length, and then what we do is make our for loop for I equals 0, I equals 0, I is lesser than length, I plus plus. We've made this many times, so you can watch the old videos if you want to see how the logic behind it. So if I is not equal to 0, then we're just going to printf the number, or comma, space the number, and this number is going to be array I. Now the next part is the else statement, which is basically if I is 0, then we're just gonna print f. We're just gonna print it plainly over here. We can even do something cool. Let's say array and then print it. Why not? We could always, we're just gonna say array.add. It's nice to work with the variables you create. And then at the end, want to make it fancy, so we'll add a full stop. And a new line, why not? Okay. Okay, let's just see if there's no errors. Okay, Command Control I to format, and let's print this array. So let's say print, or sorry, print array. We have to use our function a, and we'll print it before sorting as well. Okay. Okay, so there's a problem. We haven't done array length. So I'm just gonna put in the length myself. Okay. Okay, so we have 7653241, and it's sorted to that. Perfect. We've sorted our array successfully. Now, if you wanted to go a bit further and not want to specify these two numbers and just specify the length of the array, or maybe there's a function that can give you the length of the array, make a helper function. The helper function calls quicksort, and the first is always going to be 0, right, because we're 0 indexed, and the last is going to be length minus 1. It's a very easy thing to implement. That it's just a basic helper function for that. And yeah, we can also do something like int b, say it's a one thing array, element array, and we're just gonna have, I don't know, 2 in this array. And if we quick sort this, it's the same. It's working, right? Even for 2 elements. Now, what about 0 elements? Is it possible? Let's try it. To be honest, I'm not even sure if it's possible. I do not think it's possible. Let's see. Oh, okay. Apparently it is possible. Isn't that pretty interesting? But it's pretty useless. You would not want to sort an empty array. And yeah, so you've learned how to use quicksort. Thank you for watching.